So in this week's lectures, we talked about the host, and we talked about quite a few mechanisms of susceptibility in the host. And in particular, we covered genetic sources of susceptibility, the microbiome, nutrition, among other things. And so one of the questions that was posed was, is that a comprehensive list? Are there other important determinants of susceptibility that maybe we haven't covered entirely in the course, or that are novel areas of research? So, I mean, I think yeah, exactly. So, I mean, one thing that I'm not sure that we covered very explicitly in the lectures last week were, or this current week, were co-infections. There was some discussion about the microbiome as this whole ecology of organisms that live within you, but particularly pre-existing pathogenic infections with pathogenic organisms can very much affect your susceptibility to invading infections. And in fact, we're going to have some videos coming up in the coming weeks, both by some case study videos by Eric Harville here at Penn State and Isabella Catadori, who are going to tell some stories about the impact of co-infections on susceptibility to both bacterial and viral and helminth infections. Right?
Yeah, and I would add that apathogenic infections can also, I mean, as Marilyn pointed out, over 90% of our infections are apathogenic, and they're certainly modulating our response to the pathogens. And so, you know, don't forget the apathogenic infections here. And I get to tell a story because I haven't told one yet. You know, it's interesting, we've been talking a bit about these unusual relationships between or among different microbes. And one of the coolest ones, I think, are, of course, the retroviruses. Those are the viruses that I work on. But most, or around 10% of our genome is made up of these viral sequences. And one way that these can increase in frequency, at some point they have to be acquired, is because, you know, there's an outbreak of a retrovirus infection going on, and by chance one of those viruses infects an egg or a sperm, and now all progeny will then carry the virus. It's transmitted vertically, and it has the virus in all cells. But having an infectious, formerly infectious virus in your genome is one way to protect yourself from the infectious viruses. And so, you know, that's a wonderful symbiosis, and there's some very good examples. This hasn't occurred just once, but independently in sheep and mice, there's multiple examples of that type of relationship occurring.
So I think behaviour can be an important form of susceptibility. It can influence exposure, but even just scratching yourself is a form of sort of an immune response to removing fleas and ticks and things like that. And of course, your mucus and the way you produce your mucus, particularly for gut nematodes, is a really important response and in helping to flush out parasites and tapeworms and things like that.
I think in our modern era, with modern medicine, we tend to focus on within the body defenses, either from our own cells or adaptive immune system or through the use of some vaccine. But of course, you're right, behavior is a really crucial element there, and it's the first barrier of defense. And it hasn't been in much study, but in some cases where we have seen studies, for example, a really nice study in howler monkeys, where they're trying to remove ectoparasites. What they found there was as much as 24% of all the energy that the monkey uses in a single day goes into defending against this. We see baboons, they'll use certain plants from the rainforest to get rid of schistosomiasis, that they have that adaptive immune system. We see this in ants and caterpillars. So a lot of behavior, whether it's ingesting a product that kills the parasite or just simply moving away or grooming, these are all very useful.
So I'm going to play my card and tell a story now. But so I was doing a lot of work on grouse and ticks. The ticks bite the grouse and give them an infection. And it didn't quite add up because they didn't have many ticks, and yet they were all getting infected at a high rate. So I spent some time in the field just watching them, and other chicks were removing the ticks as they got on their siblings. So there was a huge amount of allopraning of their each siblings, and the mother taking the ticks off when they got on. And that individual then swallowed the ticks. And when they swallowed the ticks, they became infected with the virus. So it isn't it's the consumption of the vector was causing infection, not the biting of the vector.
That is really interesting.
But of course, once it's been eaten, it can't pass the virus on, it's dead.
So I would say also changes in the host behavior ecology. like for example, polio in humans, right? Everybody got polio as a newborn infant or a very young infant until we started cleaning up water. And then people didn't get polio until they were much older. So when you get it as a really young baby, you get lifelong immunity and you never get any disease. But when you get it when you're older, you can get poliomyelitis, which is obviously a devastating disease. So changes in host ecology really can change the susceptibility too.
Right.
And probably a timely example right now is with Ebola and the role of behavioral, cultural practices in that case,
Yes.
and the transmission of that particular infection, and really how difficult it is for people to change
Yes.
their cultural practices. They're very deeply rooted.
But again, these are practices that largely affect exposure
That's
explicitly rather than susceptibility.
absolutely.